Welcome back. We are going to begin Unit 5 review with example number 10 for our third video of the review. Okay, and we'll probably just get 10 through 13. We'll see how we're doing on time on this video, and we might squeeze in 14 and 15 so we don't have to make a fourth video, but we'll see where we're at. Okay, number 10, triangle MHS is similar to triangle RAM. MH is 9, HS is 6, RM is 4.5, and RA equals 3. What is the scale factor of MHS to RAM? First thing I'm going to do is I'm going to sketch myself a picture, although you'll see you probably really don't have to sketch a picture in this one, but a picture is always going to make things easier. I don't know exactly what it's going to look like to scale, and that's okay. I'm just going to make a triangle that looks kind of scalene, and then I'm going to make another triangle that looks kind of scalene, but a little bit bigger because I want them not to be congruent. I want them to be similar, so one's going to be bigger than the other. I'm going to name one MHS, and then when I label the other one, I'm going to want to make sure that the corresponding parts are in corresponding places. So the M needs to be in the same place with the R. So if my M is lower left, I'm going to make sure my R is in the lower left, and that's just so when I look at my picture, the corresponding sides will look like where they're supposed to be. Okay? That doesn't always happen, but if you're drawing the picture, you can make it happen. H needs to match with my middle letter A, and S needs to match with my last letter M. Okay? And then this question is going to ask me for the scale factor of MHS to RAM. So MHS I know is always going to go in the numerator, and RAM is going to go in the denominator. And now I'm just going to read the rest of the sentence and fill in as I go on my picture. So MH is 9, HS is 6, RM is 4.5, and RA is 3. Okay, so you can see I completely did not make this to scale because if this is 9, this should not be 3. But that's okay. I'm still going to make it work. So now what I want to do is I want to look at two sides that match each other. So I can't use this 6 because I don't have what goes with it, right? I'm not going to use this 4 because I don't have what goes with it. But the 9 and the 3 are in similar positions, in corresponding positions. MH, my first two letters, match with RA, my first two letters. And then remember to follow your arrows. I want MHS over RAM. So MHS, I'm going to use the 9 over the 3. And then it's going to want me to reduce that. And a lot of times 9 divided by 3, we go, oh, that's 3. But now we no longer have it written as a scale factor. 3 to what, right? So I'm going to write this, I'm going to keep this as a fraction, 3 to 1. So that way I know that this triangle is 3 times bigger than this triangle. Okay, even though I kind of drew it backwards, right? I drew that this one was bigger, but in the real world, this one would be 3 times bigger than this one. Okay, let's look at example 11. Which similarity postulate or theorem will allow you to say these triangles are similar? Okay, so when I look at this, my postulates that I have to choose from, my postulates and theorem are angle, angle, side, 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 and side, angle, side. So to use angle, angle, we're going to need two pairs of angles. And I see one for sure. I've got this angle here is vertical to this angle here. So I know those two go together. I know they're congruent. So I've got one angle for sure. But I don't have any other angles. We have found other angles in this type of picture in the past when I've been told these were parallel, because then we had like our alternate interior angles here are congruent. But I don't have parallel symbols, so I can't just assume that they're similar. So I only have one angle. I'm not going to be able to use angle, angle. To use side, 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 I need to have all three sides from both triangles. I've got 8, 7, but I'm missing GH. I've got 3.5 and 4, but I'm missing MN. So I'm not going to be able to use side, side, side because I don't have all three sides. So I'm going to try SAS, because that's the only one. I've got the two sides that come out of this angle that's congruent, and I have the two sides that come out of this angle. Okay, so I'm going to use those to test SAS. When I test it, again, I need to make sure that I have my up triangle, my numerator triangle, and my denominator triangle. And again, I usually just do the one on the left I put as my numerator, and the one on the right I put as my denominator. I know a lot of us out here like to say, I'm always going to put the small triangle on top so I don't get improper fractions. Of course, that didn't help me here, but that's what some of us do, okay? But I like to go left and right, okay? Now, I need to make sure I match up the correct sides. It's real tempting to go 8 to 3.5 and 7 to 4, but remember, I have to look at the two sides on one triangle and think of them as one is a small side and one is a long side. And then over here, 3.5 is smaller than 4, so this is my small and this is my long. And then we need to make sure we're comparing short sides to long sides. So my short side from my up triangle is 7. Over my short side from my down triangle is 3.5. Equals, okay, so now when I do the other one, my long from my up triangle is 8. And my long from my down triangle is 4. Okay? Now, if you have a hard time reducing fractions with decimals, because we want to make sure that these are equal, that they really do equal, are these equal, and do they equal a scale factor? Because if they are equal, that is my scale factor. Okay? Since sometimes it's hard to reduce this, okay, what you could do is just check when I cross multiply, do I get two equal numbers? Because if I do, that means that this is a valid proportion. Okay? So if I do 7 times 4, 7 times 4 is 28. And then if I do 8 times 3.5 with a decimal, I'm going to grab myself a calculator. 8 times 3.5 also gives me 28. So that means that these do reduce to the same thing. Whatever it is they reduce to would be my scale factor, and this one's easier to reduce, 2 to 1, right? So my scale factor is 2 to 1, although they didn't ask me for that. Let's see, what did they ask me? Which similarity postulate or theorem will allow you to say these triangles are similar? We tested SAS, and it worked. So that's the one that we're using. That's the theorem of the 3 to choose from. And then it says to write the similarity statements for the triangles above. So we're going to name our first triangle, and we can kind of pick it. I'm going to go with GHK. GHK is similar to, and then the order is important on the second one. If I started at G, that's at the end of the long side, then I need to start at the end of the long side. So I need to start at N. And then from G, I went down the side we don't know to H. So from N, I'm going to go up the side we didn't use to M. And then I ended up at K, my vertical angle. So I'm going to end up at K, my vertical angle. There is my similarity statement. Okay? All right. Example 12. Find the value of the missing segment. So here I've got my triangle proportionality theorem where I'm not using my parallel sides. So that means I don't have to redraw my pictures. I can just look at each side and make sure I stay consistent. So if I use this smaller piece in between the two parallel lines, if I start with 8 and I go to 20, when I stay consistent, if I started at 8 with the smaller piece down here, I'm going to start with the piece in between the two parallels. I'm going to start with 18 and go towards my question mark. So again, consistency is the key. So I started between the two parallel lines and I went to the side that goes to the corner of the triangle. So 8 to 20, 18 to my question mark. Okay? I could have done 8 to 18, 20 to question mark, right? As long as we stay consistent. Consistency, consistency, consistency. I'm going to cross multiply. 8 times my question mark is going to equal 18 times 20. Which is going to be 8 times my question mark equals 18 times 20, I believe, is 360, but let's double check our math. Yes, 360, like a circle. Divide both sides by 8 so that I can get that question mark all by itself. And my question mark equals 360 divided by 8 is 45. So my question mark is 45 units. Okay. Let's look at number 13, and then we'll say 14 and 15 for the next video. All right, number 13, find the value of x. Again, I've got my parallel lines, and I'm not working with them, which means I can just look at my sides and stay consistent and make my proportions. 8 over 6, 10 over x. So 8 over 6 equals 10 over x. Okay? When I cross multiply, I'm going to do 8 times x equals 10 times 6 so that's going to give me 8x. Oops, I don't want to do that in pencil. Pencil is my scratch work. 8 times x is 8x, and 10 times 6 is 60, so now my scratch work. Divide both sides by 8. Get rid of my pencil piece, my eraser marks, and x equals, let's see, 60 divided by 8, I'm pretty sure that's a decimal. 60 divided by 8, 7.5. There we go. Okay. All right, so there are examples 10 through 13 in the last video. We're just going to cover these last two examples, 14 and 15. And 14 is a little different, so definitely come back for that one. All right, thank you so much for watching.